So the second part of this discussion is going to take a look at how to implement the AsyncTaskBarrier framework. We looked at its API before, and now we're going to talk about how we use various RxJava operators in order to implement the semantics of the AsyncTaskBarrier framework. And this actually turns out to be surprisingly complicated. It took me several hours today to figure out all the different nuances to get it to work just right. So I'm going to walk through that. So let's go ahead and talk about the implementation. And you can get the source code here in my GitHub repository. And of course, I'm going to switch over to IntelliJ and we'll walk through the code in the IntelliJ project. So we're now in the source code for the IntelliJ project for my AsyncTaskBarrier implementation. As you can see here, we have a list of suppliers to completable tasks, which we call S-tasks. That's just a static field that's initialized to an array list, nothing too exciting there. We have a method called register, which is also not particularly exciting. And you can see what it does is it goes ahead and adds the task to the end of the task list. We have unregister, which goes ahead and removes the task from the end of the list. And then here's where the fun starts. This is called run tasks. And this is the workhorse of the AsyncTaskBarrier. And there's some really, really subtle code here that took a while to get right. So let's talk about it. The first thing we want to do is we want to make sure that the value we return from run tasks is a count of the number of tasks that completed successfully. In other words, did not throw an exception. So we have to figure out how to count that. So to do this, we're going to define a local variable called exception count, which is an atomic long. And you'll see why we make it an atomic long when you see how it's used. This is a typical trick that people do oftentimes with Java when they want to be able to update a counter inside of a Lambda expression context. The next thing we do is we define ourselves a function called error handler that's going to take any throwable, which is the base class of exception. And what it's going to do when it gets called back is it's going to increment the exception count by 1 because we just got an exception. And then we're just going to return a completed completable. So that just means that this thing is done. All right, so let's see how that gets used. So the first thing we do is we take the list of tasks and we convert it into an observable stream of tasks. So you can see here, we get a little hint that says this is an observable. It's returning an observable, which is a stream of suppliers to completables. That's what's been registered. That's how we're registering the various methods under test. This is the really interesting part. We use map. So keep in mind, remember, map is a transforming operator, which is going to go ahead and take every element it gets as input, which is this stream of suppliers to completables. And it's going to call the get operator. So this is actually a supplier. If we were to expand this out, you can see it's a supplier to a completable. And it says s.get. So the get method in the supplier is what invokes the task that we've registered, which in this case was a method reference, if you recall that. Now, this is the part that's funky. What gets returned from get is a completable. And if an exception gets thrown, then an exception will be propagated out of the scope here. But we don't want that to happen. Instead, what we want to have happen is we want to catch that exception and we want to increment this count because we want to keep track of how many exceptions we get. And we want the stream to keep running. We want to run all the various tasks that are registered in the stream, even if some of them, or even if most of them, were to throw exceptions. It shouldn't cause things to just shut down. So the way we handle that is we use on error resume next, which is called on the completable that's returned from get. And we pass in the error handler. And so what this is basically saying is whenever an exception or an error is raised on the return that comes back from get, in other words, if an exception gets thrown in get, catch that exception with this error handler, increment the count by 1, return complete, and go on to the next element in the stream. So on error resume next just says, keep going, don't bail out. So that's how we're going to make sure we catch those exceptions. It turns out that there's slightly different ways to do this in Project Reactor. If you go back and watch the videos for Project Reactor, you'll see there's a different way to do it using something called on error continue, which strangely enough is not part of the RxJava API, but that's okay. We have another way to do it. And the last thing, well, next to last thing we do here is we take the observable stream of completables. So now everything's a completable. And we use the flat map completable method. And what this does is it maps each observable element here into a completable source, subscribes to all the sources, waits until everything completes, and then it returns a single completable. So what this is doing basically is it's absorbing all the completables. And what comes back there is a completable, which just says, I'm done. It ignores all the other values. And the last thing we do, there's actually a method on completable called toSingle. And that will convert the completable into a single. And then we want that single to emit the number of successful tasks when everything's done. So here we do that by basically saying stasks.size, that was the number of tasks that were registered when we called run tasks, minus exception count.get. And this is why we use this as an atomic integer up here, because we want to be able to call this in the context of we want to be able to call this in the context of a lambda expression. And we can't do that with regular integers because they have to be final or effectively final in order to be used in the context of a lambda expression. So a little bit subtle, very tricky. There's other sleazier ways to do this by using single element arrays where you just increment the value in the single element array. That's doable, but this is perhaps a little bit cleaner. So at any rate, this is very cool and allows us to be able to catch all the exceptions and not have them propagate out of the scope, which is a big help. So that's essentially the implementation of the async task barrier using RxJava. And I certainly learned a whole lot of things implementing this because I was having a devil of a time initially catching exceptions that were being thrown from the get callbacks on the supplier. And this turns out to be probably the cleanest way to do it, in the way that allowed me to be able to log or record the fact that errors had occurred or exceptions had occurred.